Hey everyone, we're going to look at number 14 in section 3.6. We're going to find these two things, right, which are what? The second and third derivatives of the function y equals 2 times tangent x. Now, in order to do this problem, you must know that the derivative of tangent x is secant squared x, which means, of course, secant of x quantity squared, right? So you need to know that. I mean, either you know it or as I derived it for you in the lecture, by the quotient rule. In other words, tangent x is sine x divided by cosine of x, and then I can use the quotient rule. Remember, the quotient rule says derivative of the top. What's the derivative of sine of x? Cosine of x times the bottom minus the top, sine of x, times the derivative of the bottom. What's the derivative of cosine of x? Negative sine of x, all over the bottom function squared. All right, now do some simplification here. I get cosine squared x minus a negative plus sine squared x. Well, you should recognize the Pythagorean identity here. Cosine squared x plus sine squared x is just equal to 1. So this is 1 divided by cosine squared x. And remember, secant x is 1 over 1 divided by cosine of x. And so this is secant squared x. So, quick way to derive and confirm, but most of you should be knowing, learning these derivatives of the trig functions by now, all 6 of them. In fact, we're going to need secant x here in a minute, its derivative. Okay, so the derivative of y prime, then 2 is a constant multiple pulled out. What's the derivative of tangent x? Secant squared x. So the first derivative is pretty easy. Right, now to find the second derivative, I'm going to rewrite the first derivative as 2 secant x times secant x, because we're going to use the product rule on this. In the next section, 3.7, we're going to look at the chain rule, which would allow us to find the derivative of secant squared x in a different way, maybe a little bit easier way, especially if instead of secant squared, it was like secant to the 7th power. We can do the chain rule, which is what we'll learn in section 3.7. But here I'm going to write out this way because right now we have the product rule. So skip this for a minute, come down here, right? So what's the derivative of the derivative? That's the second derivative. So take the derivative of this, which I'm going to take the derivative of this. So 2 is a constant multiple, pull it out. And then secant x times secant x is product rule. I'd take the derivative of the first function, secant x times secant x plus secant x times the derivative of secant of x. Really, it's just 2 times secant x times derivative of secant x if you write that. So you need to know that the derivative of secant x is secant x times tangent x. And you can derive it similar to the way we did this, rewriting secant x as what? 1 divided by cosine of x. And so you use the quotient rule on that. And then you have to do some simplifying and using the trig identities, the definitions for secant x and tangent x to get to this. Okay, so the derivative of secant x is secant x times tangent x in each case. So notice I have secant x tangent x times secant x, that's secant squared x times tangent x. And I have secant squared x times tangent x here. So that's 2 secant squared x tangent x. And then I have this 2 out here, multiplied by 2, I get 4 secant squared x tangent x. Okay. Just a note, because we'll need this in the third derivative. By the way, this is the second derivative. Okay. That's their first thing we need to find. Now this tells us, right, because this is the derivative basically of secant x times secant x, which is the same thing as secant squared x. So in other words, the derivative of secant squared x is what this is, which is 2 secant squared x tangent x. Okay, and we did that using the product rule. But again, as I said, in the next section, we'll be learning about the chain rule, and you could use the chain rule on that as well. Okay, so we do need the third derivative, which means take the derivative of this. So again, notice this is a product. I have secant squared x times tangent x. I'll just pull this 4 out again outside. I take the derivative of secant squared x times tangent x plus secant squared x times the derivative of tangent x. So that's the product rule again. And the derivative of secant squared x, that's where I made this note up here, right, is 2 secant squared x times tangent x. Derivative of tangent x, again, we had that one before, right, is secant squared x. And so I just clean this up. I get 4 times 2 secant squared x tangent x times tangent x tangent squared x plus secant squared times secant squared secant to the 4th. Distribute the 4 through, and there's our our third derivative. Okay, so just keeps expanding more. You can imagine what it would look like if we needed the 4th derivative, right? We just have to use a product rule here, and here we'd have to hope that by then we know that the chain rule will be much easier to take the derivative of this. Okay, but we'll stop here. Hopefully this is helpful.